I'm Sachin Lohe. My project, my research project was Simplified Educational Actionable Genetic Reporting. Uh, Simplified Educational Actionable, I've kind of coined a term called C, and you'll hear about the C framework. This is part of the CS6460 educational technology. My Georgia Tech ID is S Lohe 3. So the problem statement I was looking at is to how to make sense of a growing information complexity in a genetic report and help deliver healthier outcome. We've seen that patients have now a large, very good access to all the health information. On top of it, uh, other than lab reports, they also have access to their genetic reports. Uh, those lab reports were written for the doctors, and now we are seeing information flood being added to that, which talks about certain types of genes, uh, what kind of probability exists to get certain diseases, and I read some reports around patients feeling the anxiety as they read through this information which they don't understand. So as I started looking at this problem statement, I also realized to solve that information complexity issue, there's a generic problem which we can solve is how to make sense of a growing complexity and volume in any domain. And with that problem statement in mind, I felt I can use the generic problem statement to look at information theory, cognition theory concepts, come up with some understanding from that domain, and also tie it back to solving my core problem as how to make sense of the genetic report. So let's go to the next screen. So the proposal I I am presenting here is to build a C framework. C stands for Simplified, Educational, and Actionable. We apply three transformations: the S, the E, and the A to any genetic report. What I mean by that is you take the content coming in, you try to simplify it. To simplify a genetic report, you need to, what it means is you drive interpretation and engagement. To make the report educational, you add a little bit of a context or an analogy to drive understanding. And to make it actionable, you add a meaningful data to drive action and adherence. The vision was ambitious. I believe I've landed with some techniques, and let's look at some of the techniques to simplify the content, make it a little more educational, and make it actionable. So the C framework, as I coin it, you see the input coming in this picture. The input is a genetic report. When you apply the S transformation, you will reformat the report. You will add a summary. You will try to explain a medical jargon. You may add avatars, or you may add a graph. To kind of, for folks who doesn't understand numerics, you can kind of solve the numerical literacy problem by adding a graph, which can be interpreted better at times. Uh, if you go to the educational, how do you do the E transform? You try to add an interactive guide, you add a motivational context. And when you try to make it actionable for a patient perspective, you kind of give him pointers to how to prevent, how to adhere, or how to follow up if he received a report which shows he has a positive trait to get a certain genetic disorder. And the after each transformation, you kind of go to a simple version of a report, which as output I call it the transform C genetic report. And when patient reads that report, he should be well educated, or at least understand the report better than the original report. Uh, and you see a happy patient there. Now you see a feedback loop coming from a patient into this transformation. One is his literacy, one is his motivation, and also you see another feedback loop at the bottom where the patient scoring is also feeded back. The transformed genetic report, how good it was for the patient. You can take a survey on that. Now let me explain on the input side. When the genetic report lands to do a S transform, you need to score that genetic report. What I mean by that is you can score it for an entropy score. Uh, Entropy comes from the, as we look at it, is a definition from the information theory. Here you kind of look for an entropy, the surprise entropy, and I had some challenges defining entropy which had thermodynamics definition or information theory definition. I was looking for a definition of measuring the content in it. That's where I started. That was more of a software entropy definition. So I went back to understanding how can I apply entropy into this transformation. So the one aspect I did realize as I went into understanding where a real entropy in an information theory sense can make sense is when when a patient sees a lab report saying he is positive for a certain trait, or he is positive to get diabetes as he ages, or cardiovascular diseases, that's kind of a surprise for a patient who probably is not expecting that surprise. A status quo is not that much of a surprise for him. So if there's a surprise, which means there's a high entropy. And as we look at some of the research paper I read, high entropy implies you need to do a little additional learning to reduce the entropy. And as you learn, entropy reduces. And that's kind of also an indication of learning. So that was one of the key things I learned during this project. I always had a hunch that entropy is high at the start. If you learn, entropy should reduce. So that was a good indication. Then I also came across a research paper which said uh, entropy, when you have high entropy from a content, it reduces initially as you learn, but when you learn, you also discover new areas which are more unknowns, more surprise, so your entropy again go back up. So it's kind of a sine wave, but overall the entropy decreases as we learn. That's at least the hypothesis we are going to go with. Then there is a concept called readability score. Uh, Readability means you have grade score, like is the content readable by a fifth grader or eighth grader or a 13th grader. So as you look at this genetic report, you kind of can give a standard readability score, and I'll present that in the um, next slide. This readability score kind of tells you, or we are trying to improve the readability score by bringing it from 8th grade to 5th grade so that anybody can read this report. So that's where it is. And what I'm presenting here is you will score a genetic report, and then you also have sample genetic reports stored in a repository which is outside this framework, but that's also a proposal as a part of this research, that you will implement a repository of genetic reports which will be surveyed by humans uh, to kind of, and that's what I call it the H score. You see the auto score, which includes entropy. You can measure a redundancy score in a document as to how much is the redundancy. That comes from an information theory concept that uh, the more the redundancy, the more compression you can do, so you can reduce the content of the report. And then we talked about readability score, where you improve the grade. The human score, as you see at the bottom, is the purpose, the outcome, the result, the diagnosis, the medical management, the satisfaction, the health outcome. That's the human dimension of a genetic score. You need to have a clear purpose, you need to know a clear outcome, you need to have a clear result. So we kind of score those reports, and both the scoring, the auto score and the human score, kind of drives some of this transformation. If a score is already good, then you don't need to transform that report much. Now, I do know that my mentor did ask me, what about if you translate a good medical report which is understood only by the doctors? That's another challenge I've seen in this domain. The genetic reports were written mostly for the doctor, the medical language that was not implied to be understood by the patient. As we start having more e-reports, there's more and more need for the patient to understand this genetic report. So you'll see an example where medical language is not understood. So the point being, when you have the score can be used to drive the transformation as to what level of transformation you want to carry out on a genetic report. Do you go completely on one extreme to simplify it? Do you transform it a little bit to keep the original text and keep the new text? And that's where one of my mentor did recommend me just what are the legal implications of it if you drive a transformation to misinterpret, or can it be misinterpreted, and there can be challenges of those kind. My proposal is keep the original text which is understood by the doctor, also keep the simplified text. That's my proposal. And then there are consumer health vocabularies, and there is a glossary of Human Genome Institute which may drive the e-transformation if you need to add an interactive guide, or you need to recommend prevention adherence steps. There's a machine learning AI dimension to it where the scoring can be improved, tuned as machines learn from various genetic report. I didn't get time to research into that area, but my paper does recommend or reference that dimension. So let's go to the next slide to look at an example. So I did mention the C framework scoring engine. I mentioned the auto scoring. I mentioned the human scoring. I referenced that human scoring can be done via surveys sent to population, or and then it can be helped to create models of simulated patient and consumers. So let's define the goal of the C framework. The goal is to improve scoring of a report content and drive understanding and comprehension of report content for patients. So the output report should have a better score, which implies it can be easily comprehended by this patient. We will also score the transform genetic report as I mentioned, and with the auto score and a high score, which is HI score, means human generated individual score. Once the report comes out, the human who is getting the report can also score and say I love this transformed genetic report or not, and then uh, we can apply the machine learning to keep improving the scoring, or we can rerun a transformation if we need to. So let's take a sample genetic report. The sample genetic report here shows uh, the patient date of birth, the person who did it, and the specimen received for chromosome analysis. And the chromosome results are displayed, and then there's a interpretation of that result. This interpretation says metaphase cell analyzed revealed an abnormal female chromosome complement with additional chromosome 21 seen in each metaphase. These results are consistent with trisomy 21. That's kind of the report, genetic report a patient received. Now let's look at what will S transform do. The S transform will take the original text, and it had a readability score of 13.36 as read by the Flynch Kennard grade level. If we transform it, the transform text, and I haven't proposed how a transformation logic will work, but we'll make an assumption that there is a way to transform that original text to a simple language by looking up synonyms, looking up which synonyms are understood at what grade level, and assuming that transform uh, or or another proposal is a Google translation or other engines which are out there can be used to come up with a simple language. But the overall interpretation of the transformed is the patient is going to have a kid which has a Down syndrome, and I kind of tried to transform it into a simple language. The results of lab indicate a Down syndrome. Down syndrome, also known as trisomy 21, is caused by 3 copies of gene on chromosome 21 rather than usual 2. And the score, the grade level of this transformed text is 8, which means a 8th grader can understand this text. So that's this S transformation. Let's go to E transformation. The E transformation is we haven't mentioned anything. What is a chromosome 21? So here in the original text you just had a content, you didn't have any picture or a visual. Here you can see there's a visual here which shows you that the chromosome 21 has 3 copies and it should have only had 2. So that's kind of a good indication of a Down syndrome. Let's go to the A transformation. Actionable transformation, there was no action mentioned in the report. So in the A transform, we kind of add a couple of lines saying we recommend a follow-up genetic counseling for this patient. We give him the helpful links. And with that, I want to say in the closing remarks, C framework enables humans to see through that vast sea of information by proposing 3 transformers S, E, and A. Each transform play a special role in simplifying information, add additional context to drive understanding, and enable decision making. So I want to give an example here. Dyspepsia implies indigestion. So the word indigestion can be easily understood by a patient who has never heard dyspepsia. Dyspepsia is a doctor term, and if we can translate that to indigestion or hard to digest, that's an easily understood term. Now, to drive a context, you can give additional context. A patient who doesn't come from a medical domain, but if you're trying to explain it to a mechanic, you can add a context saying something in the engine is not getting uh, adjusted, or you cannot consume the fuel. It's sitting there. It's not converting to another energy. That can be a context you can give to a mechanic trying to explain what is dyspepsia. And then enable decision making is you're telling him what action or to take to get rid of the situation. So that's another example of adding a context, a personalized context to a patient. You first simplify, you add a context so that he can link his thoughts to other domain expertise, and then you enable him to make a decision making. And that's all what the information we receive should be all about. It should enable us to take actions and act in the world. Now, implementation proposal for C framework should support integration hook for each of the three transforms to take advantage of advances in information theory, cognition theory, and all future endeavors to tame the information flood and drive information understanding. The two techniques I reviewed to measure report simplification included the readability score and entropy. Uh, so what I'm proposing here is you want to have pluggable hooks into those SE and A transform. I'm not proposing they should be sequential. They can be run in parallel on the same content, so you can have better efficiency. But what I'm also recommending is integration hooks, which enable this SE and A transforms to plug in new modules, plug in new additional context a patient can have as the information in the world improves or any new techniques are discovered in the cognition theory or information theory world. The better readability score enables improved comprehension of a genetic report. High entropy score hints at unexpected surprise from a positive genetic report. That's something I was referencing at the start of this message. And that implies the patient needs additional simplified educational context, and then that should make it action, and also we can make it actionable input to reduce the entropy. So to repeat that concept, high entropy implies there is a more surprise in the content of the genetic report. To reduce the entropy, you need to allow the patient to learn, and the way you learn is you simplify, you educate, and you drive actions for the patient. Successful implementation of C framework in genetic reporting will help drive healthier outcome for all the living species. And some of the references I wanted to mention, key references. I have all other references mentioned in my presentation, but uh, the key references were developing a patient-friendly genetic report, genetic and genomic report formats to promote patient engagement and understanding. That was very helpful to understand this market is growing from $5 billion to 20 plus $1 billion by 2021. So when as patient gets access to more and more of this data, we need to help them drive understanding, reduce their anxiety, and drive drive more actionable inputs for this patient. Uh, then there was a very good paper I came across, a relation between emotion and entropy, and that talks about the same concept about how emotional surprise drive a higher entropy, and how do you help that emotion uh, to be reduced by a learning. A new way of linking information theory and with cognitive science. Again, the same concept, linking information theory and cognitive science. Does learning imply, the fourth reference is, the learning imply decrease in entropy of a behavior? That again was a good reference. It shows that sine wave that learning helps decrease entropy, but as we uncover new areas, again the entropy goes up. So, but it starts showing a decreasing trend unless an agent uncovers a totally new area of knowledge where the entropy again goes up. With that, I want to present to you all a C framework, and I hope it helps build um, simplified tools, or tools which will enable comprehension of this growing data and help humans to absorb new knowledge and tame this information flood. Thanks all.